Hi, my name is Tovah, and I'll be talking about the effect of experience on collective decision-making, which is my Master's of Science project. So we'll begin by talking about expertise, which allows individuals to outperform novices on a complex task. Fundamental features of expertise include extensive experience and practice with a complex task, better knowledge, attention, and decision-making abilities, and also improvements in coordination and speed to physically carry out the task. An interesting but unexplored phenomenon is group expertise. When individuals are grouped together to accomplish a difficult task, they gradually improve their performance. So factory workers, for example, in an assembly line, can increase their speed of production and decrease their error rate as they gain experience. Some of this improvement can be attributed to individual level learning, but there can also be group level changes. So for example, improvements in communication or developing more efficient routines. And expertise has primarily been studied in humans, but there is evidence of expertise in non-human animals. For example, individual honeybees can increase their net rate of food delivery as they gain experience feeding on complex natural flowers. And wolf packs improve their hunting success as they age and gain experience. We as humans rely on group expertise for many aspects of life, for example, surgical teams, factory workers, businesses, engineer teams, and scientists. But despite how prevalent this is, we lack a fundamental understanding of how both individual and group expertise develop. And because we see that expertise exists in non-human animals, it's not only important to understand expertise beyond humans, but we can use non-human animals to study it with controlled experiments. Within group expertise, collective decision-making is crucial in order for the group to maintain functional and cohesive. An incorrect decision could cost the group time, energy, money, food, or even mortality. But it is currently unknown whether a group's collective decision-making ability can improve with this experience. So we want to know if repeated experience on a decision-making task can improve the speed and efficiency with which a group reaches consensus. Our hypothesis is that experience with collective decision-making will improve group performance on future decision-making tasks. We're measuring the behavior of choosing a new nest option during emigration in Temnothorax ants, also called acorn ants or rock ants. So if their nest becomes inadequate, if it's damaged, for example, or if they just find a better quality nest, they can relocate their colony to that new nest. So in nature, decision-making is a large part of emigration because there's many possible nest alternatives, but only a few are high quality enough that suit their colony. And colonies must also choose a nest quickly because they physically carry the queens and young to that new nest, making the lifeline of their colony extremely vulnerable to predators and environmental conditions. So this emigration process is divided into 3 phases, and it begins when we remove the roof of the lab nest, making it uninhabitable. During the discovery phase, workers will actively seek out alternative nest options. And then once they find the nest, they assess the quality using the help of colony members. And then they begin the transport phase, where workers physically carry the remaining colony members to that new nest. And only a minority of the colony members actually partake in emigration. Most of them will either be carried there or walk there themselves. So we are testing the effect of experience on choosing a nest option during emigration as a measure of group expertise. So we predict that colonies with experience choosing between 2 nest options will be both faster and more efficient at decision-making than colonies with no experience choosing between 2 nest options. To test our predictions, we first run a training phase where we provide colonies with experience emigrating either with or without room for decision-making. We have 40 colonies divided into 2 groups. So in the choice group, they are always provided with a good quality nest and a mediocre quality nest. And the quality depends on the amount of light that enters the nest cavity. And then the no choice group gets either a good quality or a mediocre quality nest option, leaving no room for decision making. Both groups undergo 6 emigrations during training, and we randomized and counterbalanced the placement and order of the nest on the arena for each emigration. And then after training, both groups are tested on the same decision-making task, which is a choice between a good and a mediocre quality nest. So this is an ongoing experiment, and we've processed data from the first 20 colonies, and we're currently processing data from the last 20 colonies. So to test our first prediction that the choice group will be faster at decision making than the no choice group, we're measuring decision latency, which is the time between the first transport until the first discovery. So we use this measure because it isolates the decision-making process by including the discovery and the assessment phases, and then the choice to begin transporting into that new nest. So this is data from the first 20 colonies. On the y-axis, we have decision latency in seconds, and on the x, we have colony experience, either with choices or no experience with choices. So we see that the decision latency on average is shorter for the choice group compared to the choice group, meaning that they're taking less time and they're choosing to emigrate faster than the no choice group. So far this is in line with our first prediction. So to test our second prediction, that the choice group will be more efficient at decision making than the no choice group, we're measuring the proportion of transports directly to the better quality nest. So we use this measure to capture efficiency of transporting directly to the better quality nest, as opposed to transporting to the mediocre nest, or from the mediocre nest to the better quality nest. So on the y-axis, we have proportion of transports to the better quality nest, and on the x, we have colony experience making choices or no experience making choices. And we see that the proportion of transports to the better quality nest seems to be on average higher for the choice group compared to the no choice group, meaning that the choice group could be more efficient at decision making, which is also in line with our second prediction. So with our data so far, it seems that experience with collective decision making does improve group performance. So now we want to know how that improvement happens. So to test this, we've individually marked ants with unique color combinations in 8 colonies for identification. And this will allow us to observe individual and group level changes over time. So again, we're currently processing these videos, but we plan to measure individual level changes so that we can see how individual decision-making latency can change with experience, which is basically the tendency for the individual to assess the nest and then accept it and begin transporting there. And then we also want to see if the proportion of ants participating in the emigration will change over trials. We will also measure group level changes by mapping out social interactions through a social network analysis. So social networks will allow us to see how the social dynamics change over the course of the trials. This will help us understand how the improvements in collective decision-making arise from the actions and interactions of individuals. Our research is one step forward to understanding how collective decision-making plays a role in the development of group expertise. So I'd quickly like to thank the people that have helped me on this project. And thank you very much for listening, and feel free to email me with any questions you have.